If you want the full Vista experience, you'll want a heavy system and graphics hardware and lots of memory.
Wow. That is a blast from the past. I haven't heard anyone recommend a heavy system for Vista in, what, 15 years?
I know, right? It feels like we're doing digital archaeology here. But stick with me, because that sentence, as dated as it is actually perfect for what we're talking about today.
Okay, I'm intrigued.
On the surface, it seems so simple, just a tech recommendation. But if I just say to you, you want the full Vista experience, or, you want a heavy system.
Right, they're just floating facts. They're noise.
Exactly. They don't actually tell you why you need to go out and buy all that expensive hardware.
You lose the logic. If you chop it up, there's no causal relationship anymore. It's just a shopping list without a purpose.
You got it. It's that tiny word in the very beginning, if. That if is doing a surprising amount of heavy lifting. It turns that whole list into a condition. It says, if you do A, then B happens.
And getting a computer to understand that if, to see that invisible glue connecting the ideas, that is surprisingly difficult. It is one of the hardest problems in natural language processing.
It really is. And it's the difference between a computer that can just, count keywords.
Yeah, find the word Vista on a page.
And a computer that actually understands what you mean when you ask for advice. So today on the Deep Dive, we are looking at this hidden architecture of language. We're digging into a paper called Benchmarking Automated Approaches for Tagging Discourse Relations by Shamima Mithun and Leila Qasim from Concordia University.
And the mission here is really specific. We're not just looking at spell check or basic grammar. We're looking at how researchers are teaching machines to spot those invisible connections.
The discourse relations.
Right, or as they sometimes call them, rhetorical predicates.
Okay, rhetorical predicates. That sounds like something I definitely would have just glossed over in a college textbook. What are we actually talking about with that term?
It sounds intimidating, I know, but just think of it as the Velcro between ideas. Text isn't just a straight line of sentences, one after another like a grocery list.
It's not linear.
Not at all. It's a hierarchy. It's a structure. One clause explains another, or it contradicts it, or it gives an example of it. And to really understand a document, you have to categorize how all these little pieces relate to each other.
So it's the difference between reading a dictionary and reading a story.
That's a great way to put it. The dictionary has the words, the story has the relationships.
And if we can get computers to do this, the payoff is huge.
Oh, massive. We could unlock automatic summarization that actually makes sense, or, search engines that can answer complex why questions instead of just finding pages with the word why on them.
And the authors of this paper didn't just theorize about this Velcro. They actually took existing AI tools, the state of the art at the time, and they even built a new one to see just how good they are at this.
Yeah, they put the machines to the test. They wanted to see if computers could figure out the context, not just count the words. Can the software tell the difference between a fact and an opinion, or a cause and an effect?
Okay, so before we get to the results, which, spoiler alert, are a bit of a roller coaster, we need to understand what the machines are even looking for. The paper breaks these discourse relations into 6 types.
And the examples they used from their source text, they were surprisingly spicy.
They really were. They used a bunch of blog posts and product reviews, which are, super opinionated.
Which is perfect for this. It's how people actually talk, not how they write in some formal essay.
It's the messy internet, which is where we need AI to work. So let's run through the 6 types. The first one is comparison.
This is pretty intuitive. It's just when the text compares or contrasts 2 things. And the example they pulled was, perhaps that's why, for my European taste, Starbucks makes great espresso while Dunkin' stinks.
Tell us how you really feel about it. But okay, yeah, clearly contrast. Great espresso versus stinks.
Right. But for a computer, that's tricky. It has to understand that the word while isn't talking about time.
Good point.
It's not saying Starbucks made coffee at the same time that Dunkin' stunk. It's setting up a fight. It's a contrast marker.
That's a really good point. While is ambiguous. It could be time or it could be a conflict. Okay, next up is contingency. Sounds a bit more legal.
It covers cause, condition, evidence, result. Basically, it explains why something is the way it is. The example was, the meat is good because they slice it right in front of you.
The because That's the contingency. It links the quality of the meat to the action of slicing.
You've got it. It's the causal link. The computer needs to know the slicing is the reason for the goodness.
Then we have illustration. This is when you provide more detail or you elaborate on something.
Right. And the example here was, I have a special relationship with the lovely people who work in the Dunkin' Donuts and the Harvard Square Tea Station.
I love the specificity there.
Yeah.
The Harvard Square Tea Station.
And that's the key. The writer starts with a broad concept, a relationship, and then illustrates it with a specific location. It's drilling down.
Okay, then we get to one that I think trips up humans, let alone machines. Attribution.
This is a huge one, especially for news. Attribution is about reported speech or feelings or thoughts. It's so crucial for telling facts from claims.
Like their example. I said, actually, I think Zillow is great.
Exactly. The fact there isn't that Zillow is great. The fact is that I said it, or I think it. If an AI just summarizes that as Zillow is great, it's completely failed.
It's missed the most important part.
It needs to know it's an attribution of an opinion to a speaker.
Yeah.
It's not an objective truth about the housing market.
That distinction is everything. Which leads us right into the next one, topic opinion.
This seems simple at first glance. It's just expressing a feeling toward an object. The example was, the thing I love about their sandwiches is the bread.
So the relationship links the feeling love to the topic, bread.
Precisely. It's not just bread exists. It's bread plus this positive emotion. Capturing that link is how a system knows if a review is good or bad.
And finally, number 6. This is the one the authors actually added to the mix themselves because they felt it was missing. It's called attributive.
Yes, the attributive relation. And you don't want to confuse it with attribution. This is just describing features of an object. Simple description, like Mary has a pink coat.
So it's just describing the world. The coat is pink, the screen is wide.
Exactly. It seems really simple, but if you're trying to pull product specs from a review, you have to be able to catch these descriptions.
Okay, so we have the 6 categories. Now, this is where the paper took a turn that I found really interesting. It's not just about what these relations are, but where they happen.
Ah, yes. This is a critical technical point. We have to talk about intersentential versus intersentential.
Inter versus intro. Break that down for us.
So inter just means between two separate sentences, from one period to the next. Intra, on the other hand, means happening inside a single sentence.
Why did that matter so much? I mean, a relation is a relation, right?
You think so, but historically, a lot of this kind of analysis focused on the big picture, how paragraph A connects to paragraph B. But this paper argues that for something like extractive summarization...
Where you're just pulling key sentences out of a blog to make a quick summary?
Exactly. For that, you absolutely have to understand the relations inside that one sentence you pulled.
Because if you pull a sentence out of context, you could break the logic.
Or worse, you could completely invert the meaning. Imagine a sentence like, I usually hate horror movies, but this one was fantastic. If the computer only sees the first part, I usually hate horror movies, and misses that but.
It thinks you hated the film.
It misses the intersentential contrast entirely.
And the data in the paper backs this up in a big way, doesn't it?
Oh, they cite this really impactful statistic. They looked at a massive corpus of 4.7 million Newswire documents.
That's a huge data set.
Huge. And they found that 95% of causality, cause, and effect happened within sentences.
95%.
Okay.
Wait, 95%? Yeah, I know.
So almost all of it, all the why, is buried inside the sentence structure itself.
Yes. So if your AI tool is only looking for connections between sentences, which a lot of older tools did, it's missing almost all of the because logic in the text. It's flying blind on causality.
That is a massive blind spot. Okay, that explains why some of those old auto-summarizers were so bad. So let's talk about the toolkit. How do you actually teach a machine to do this? The paper looks at 4 different approaches.
Right. They look at the state-of-the-art tools at the time. First up, we can call this one the architect. It's technically called the Spade parser.
Spade. Like
Yeah.
the card. How does the architect work?
It uses something called rhetorical structure theory, or RST. It basically tries to build a discourse tree for the sentence. It breaks
Yeah.
it down into these little elementary discourse units.
So it diagrams the sentence like we did on the chalkboard in school.
Sort of, yeah. It looks at the syntax and tries to map out the hierarchy. And is really good at spotting relations between clauses. But it had a major limitation. Let me guess. It couldn't see the furniture inside the house.
That's a perfect analogy. If you say Dunkin' Donuts coffee tasted better than Starbucks, that whole thing is a single clause. Spade just sees it as one block.
So it misses the comparison completely.
It doesn't break it down further, so yeah, it misses it.
Okay, so the architect is great for the big picture, but misses the detail. So what's next? The pattern hunter. This comes from a study by Jindal et al.
The pattern hunter is much simpler, in a way. It doesn't build a big tree, it just mines for keywords. It looks for words like more and then or better.
So it's looking for a recipe, like a formula.
Exactly. It mines for patterns like adverb, adverb, verb, the word more, preposition. If it sees that sequence, it flags it as a comparison. It doesn't really understand anything.
Yeah, it feels a little brute force.
Right.
Like just using Control F to find meaning.
Hmm.
But I guess if you see better than, it's probably a comparison.
And it's surprisingly effective for that one task. But it totally fails when things get more abstract. Which brings us to approach number 3. Fay et al. We can call this one the grammar nerd.
The grammar nerd. I like it. How did that one work?
This approach uses dependency relations. It builds a grammar tree where every word is a parent or a child of another word.
Okay, walk me through an example. How does it trace a thought?
Okay, take the sentence. Subway has bad food. The grammar nerd starts with the subjective word bad. It sees bad is modifying food, then it sees food as the object of the verb has, and Subway is the subject of has.
So he draws a line basically from bad all the way back to Subway.
Exactly. By tracing that lineage through the verb, it figures out that the bad opinion belongs to the topic Subway.
So we have the architect, the pattern hunter, and the grammar nerd. But the authors of our paper felt something was still missing.
They did. They realized nobody had a good tool for that 6th category we mentioned, the attributive relation. Things like Picasa displays the zoom percentage, just simple descriptions.
The other tools were just ignoring them.
Totally ignoring them. They weren't opinions or comparisons, so they fell through the cracks, so they built their own.
They became the attribute hunter.
Pretty much. They also used dependency trees, like the grammar nerd, but they created their own specific rules. For example, if a verb is linked to a topic with a nominal subject tag, that's a specific grammar tag, they'd flag it as a potential attribute.
They basically taught it, if you see this very specific grammatical setup, pay attention.
That's the gist of it. They customized the logic to catch the boring but important stuff everyone else was ignoring.
Okay, so we have the contenders, we have the tools. Now for the showdown, they ran these against a data set to see who won, right?
They did. They measured it using the F measure, which is a score that balances precision, which is when you guessed, were you right? And recall, which is did you find all the examples?
Right, the balance of quality and quantity. And they compared it all against a gold standard.
Yes. The gold standard was just a set of documents that human annotators had already read and agreed on. Basically what humans thought the text meant.
So, who are the winners?
Well, for illustration-giving examples, Spade, the architect, was fantastic. It hit an 85% F measure. It's really good at seeing when one clause elaborates on another.
And what about comparisons?
The pattern hunter, Jinmen's approach, took that one, 81% F measure. Turns out, we use really predictable language when we compare things. Better than, more than.
It's formulaic. X is larger than Y.
Okay, that makes sense. But I'm guessing there were some losers. What was the hardest thing for the machines to get?
The hard stuff was definitely attribution and topic opinion. For attribution spotting reported speech, Spade only got a 64% score. It really struggled to separate the speaker from what they said.
And opinions.
Topic opinion was the hardest of all. Even the grammar nerd, the state-of-the-art, only got to about 70%.
Then why is that one so hard? Is it sarcasm? Is it just that we express opinions in really weird ways? It's all of that. But here's where it gets really fascinating. And I think this is probably the most important insight from the whole paper. They looked at the gold standard for topic opinion.
The human agreement score.
Right. They checked how often the human annotators agreed with each other.
Okay.
And the agreement between humans on what counted as a topic opinion relation was only 75%.
Wait. Pause there. You're telling me that 1 out of 4 times actual human beings couldn't agree on whether a sentence was an opinion about a topic.
That is exactly what the data showed. 75% agreement.
That's wild. That changes the entire context of the machine's failure.
It really puts the computer's struggle into perspective, doesn't it? If we can only agree 75% of the time, how can we possibly expect a machine to do better than 70%?
The machine is getting pretty close to the human ceiling.
It's bumping right up against it. It's like we're trying to teach a computer to be objective about something that is inherently subjective. I mean, opinions aren't just keywords. They rely on cultural context, tone, irony. Think about a review that says, I love the movie except for the acting, the writing, and the directing.
Right, the sentiment calculator sees the word loved, but the actual meaning is hated.
Exactly. Or even the sentence, "It was a quick read." For a thriller, that's a compliment. For a textbook, it could mean it lacks depth. The context changes everything.
So this paper, what it's really showing is that while we're getting great at teaching computers the structure of language, the skeleton, the comparisons, the illustrations, we're still really struggling to teach them the soul of the text. The opinions, the attributions, all the messy human stuff.
We can teach them syntax, but semantics, the meaning behind the words, that's still the frontier.
So let's bring this back to the so what for everyone listening. Why should we care if a computer can spot an opinion? Why does this research matter to someone just trying to browse the web?
Well, think about the information overload we all face. We want computers to summarize blogs and news for us. We want AI tools to digest thousands of reviews before we buy something.
Right, I don't want to read 5,000 reviews of a toaster. I just want to know if it toasts bread evenly.
Exactly. But if the computer can't tell the difference between a fact like this toaster has 4 slots and an opinion like I think this toaster is ugly, then the summary it gives you is going to be misleading.
You might end up with a summary that just says the toaster is ugly, as if it were a technical spec.
Or worse, it'll strip out the why. If you want to ask Google, why is this product popular, you need the system to find that contingency relation, the because. You don't want a list of keywords, you want the causal link.
So solving this helps us move from searching for just strings of text to searching for actual knowledge.
That's it. It's a difference between finding a document and understanding a document.
The difference between a librarian pointing to a shelf and a librarian actually answering your question.
Well put. And this paper, by benchmarking all these approaches, it really shows us where the gaps are. We've got good tools for the structural stuff, but the more subjective relations, they need a lot more work.
And maybe that work starts with us humans just agreeing on what we actually mean when we speak.
That might be the hardest engineering challenge of all.
It really is. You know, it leaves me with a final kind of provocative thought to end on. We always talk about AI accuracy and needing AI to be perfect. But if the gold standard for human interpretation of opinion is only 75%, are we asking computers to be more objective and more understanding than we're capable of being ourselves?
That is the ultimate question, isn't it? We want them to be perfect mirrors, but maybe we're just holding up a cracked reflection to begin with. We're asking them to be better listeners than we are.
Something to think about the next time you ask a chatbot for a summary. A huge thanks to the authors Mithan and Kossam for this fascinating look under the hood. It's older research, but the problems are still incredibly relevant. And thanks to you, as always, for helping us connect the dots.
My pleasure.
And thank you for listening. We'll catch you on the next Deep Dive.